Hello and welcome. This is a AQA A2 past paper. This is for Unit 4, Section A, June 2013. Now, this is the first A-level past paper, Unit 4, that I'm doing. Now, I'm sorry for the recent lack of uploads. I have been kind of quite busy just going over all the stuff again because, obviously, leaving it over the summer. It's good to get a refresh before you start doing videos and then go, oh, what the hell am I going on about? Okay, so as with all Unit 4 past papers, the first question is always, or always has been so far at least, a momentum question. Now, because of I've got myself, my past teachers have given me these papers with their model solutions for the Unit 4, please do feel free to, because you can find my email on the channel. If you go to the About section on the channel, there is a email description. It's just business, but you can just use it just simply to contact me, as well as commenting on the videos. And I can email you these past papers that I've been given, okay, with model solutions written on them. It's as a PDF document, so one I can just email, you can open up on your computer. Alright? I know you're not all 50, so you know what a PDF is. But anyway, let's crack on. So, the first question says, what is a possible unit of impulse? Now, that's the other thing as well. They try to, because momentum questions, let's be honest, are all basically the same, they try and make them more difficult by using terminology. Okay, now impulse, you've got to understand this, okay, as opposed to, you don't have to. You've got to understand that impulse simply means a change of momentum. Okay, so what you're looking for there is units of momentum. Okay, the fact that it's a change of momentum is irrelevant. Okay, just got to understand it's basically asking for the units of momentum. Okay, so you've got to think, well, what is a change of momentum? Now, it's not a rate of change of momentum. Okay, so it's not the force. So all equations, really, apart from this one almost, will be using this equation in in the first question. Okay, so it'll either be a graph or asking something like this, so about units. Right. So what we're looking at is a change of momentum. So it's delta mv. Okay. So what are the units for mass and what are the units for velocity? Okay. The units don't change when you're looking at the velocity after and before. Okay. In this sense, so what you're looking for is units for mass, which is kilograms, okay, and units for velocity, which is metre per second. So when you times kilogram by metre per second, you get kilogram metre per second. So you're looking for some variation on that. So let's do the possible answers, and if we can see that, great. If we can't, then we've done something wrong. Okay, as you can quite clearly see, I can't get it up on the screen next to me, although I might just put a picture next on the side of the screen. I might do that. Depending on how I feel in my technical ability. Okay, so that comes up as option B. Okay, so for 1, the answer is B. Put a little list there. Okay, and the rest are relevant. Okay, now A and D, by the way, you can counter off straight away because A and D in the options are a variation on Newton per second. Okay, and Newton per second would be this. The F, okay, because any force, it's relevant what this equation is equal to, can be measured in newtons. And because we've got a time here, obviously put Newton per second, okay, so that'd be for the force. But remember, impulse is simply a change of momentum, so you're looking at the mass kilograms times velocity, which is metre per second, okay. Now, the other option, C, is metre per second squared, which metre per second squared is only ever seen in acceleration. Okay, as far as we're concerned anyway. Alright, so that's why question 1 is answer B. And as I said, I do have model solutions for this, so just let me know in the comments. You might have to actually talk to me, but still, you'll get an answer. Okay, so following on from question 1, obviously, with another question 2. Now, with these questions, they all kind of follow the same thing. So question 1 and 2. And question 1 will always be a momentum question, and depending on how hard that one is, as you can see, that was very easy. if it's easy, you tend to get a few more momentum questions as well. So like this one. And basically we're told that a railway truck of mass 800 kilograms is travelling along a level track at a velocity of 2.5 metres per second. So initially we've got two bits of information there, and it collides with a stationary truck of mass 1,200 kilograms, and then they both move together after the collision. Okay, so it's a very easy momentum question when you take into account what's actually happening. So, I mean, I know it's not asking you about it, okay, but because they both move off together after the collision, okay, it is what is known as a totally inelastic collision, okay. Now remember, inelastic means there is loss of kinetic energy, and if it's totally inelastic, that means they move together, okay. So if you're ever confused about, if it's totally inelastic or not, or if it's inelastic or elastic, just remember that one, it'll help you distinguish the two, okay? Anyway, waffling. So, as I said, we've initially got this 800 kilogram truck, very artistic drawing we've got here, just a block, which is 8,000 kilograms, sorry. And a 1,200 kilogram truck. Yep, sorry, thought that was a bit light for a truck. So as I said, we've got this 12,000 kilogram truck and this 8,000 kilogram truck, and this one is initially moving at 2.5 meters per second, and this one is moving at 0 meters per second. In other words, stationary as it's set. Okay, and what we want to know is the end velocity after the collision. Okay, so the velocity of both of them afterwards. Now, what you can do is this. Now, I call generally the truck furthest to the left truck 1. So I'll put T1 and obviously the other truck 2 following the same. So what I tend to do is break it down. Now, obviously this is a very easy one because they're going to be the same velocity. So the end velocity is going to be the same. You can both call the end velocity of both of them V. Okay. But just to help you understand and apply to other questions, U1, okay, is the speed of truck 1 initially, and U2 is the speed of truck 2 initially. So you can write it down if you want to, 2.5 meters per second. Remember, we are talking about velocity here, so you're going to need a positive and a negative direction. But as they both will end up going the same way, and they're both going to, neither truck is going to go left, okay, we can call them as we can take the positive direction as this way, okay, as the way they're going. But obviously if one was going to rebound the other way, then you would need to take into account the fact that the velocity is going to be negative at some point. But as they're both moving right, we can take it all as a positive velocity, okay, so do be aware of that, because that can catch you out in these questions. So V1, okay, well we don't know what the end velocity truck 1 is, and the end velocity truck 2, okay. So because the velocity of both trucks at the end is going to be the same, we can just call it V, okay? Now that might look confusing, you could just call it X or whatever, okay? Some number, okay? So the key bit with all of these is the total kinetic energy before is going to be equal to the total kinetic energy, sorry, oh, God's sake, what the hell am I going on about? Total momentum, sorry, something you need to learn, yeah, I need to learn, anyway. Total momentum before is going to be equal to total momentum afterwards. Okay, so obviously to do that you need to work out total momentum before, but I'm just going to put that equal to total momentum after. Okay, so it's going to be 8,000 kilograms times 2.5 meters per second, okay, plus the 0 times 12,000, or you can just put plus 0 in brackets, okay. But if this was a marked question on a section B paper, you would need to put there the 12,000 times 0 to show where you're getting the 0 from, but as you don't get marks for the working out, you don't need to put that 0 at all. But it's just to help you understand, you would have had something there had it been, marks for working out. But as I say, just wasting time, which is what I do best. Okay, and that's equal to total momentum afterwards. Now there's no point putting 8,000 times V plus 12,000 times V because they're timed by the same velocity. Okay, so you can simply just do a skip step because, as I say, you're not being you're not being given marks on your working out. So you can just combine the masses because they're moving at the same speed as, take it as one big mass, okay? So it's going to be, obviously, your 20,000 kilograms times V, okay? Now, as I said, if we were doing it properly, we'd do 8,000 times V plus 12,000 times V, okay? And then add that as a separate step. But because we can skip steps here, we shouldn't, but obviously you're not going to know why, apart from reading and writing. But anyway, so you work out what this is, the 8,000 times 2.5, which is obviously going to be 20,000, because 2 times 8 is 16, and half of 8 is 4, so 16 plus 4 is 20. So it's going to be, they're both going to be 20,000 kilogram meters per second, okay? So therefore V is going to be 1. Now I just did that off the top of my head because that's a really easy calculation. So it's going to be moving at 1 meters per second. But as I say, if you were given markings or you did it properly, what you would do is work out this, divide it by 20,000 and get V. But as this comes to 20,000 anyway, you can quite clearly see that. You just say V is 1 and you save yourself a few minutes in the multiple choice. And what we're actually being asked, okay, so this isn't the end answer, sorry. What we need is to be able to work that out. The actual question is, what was the change momentum of the 8,000 kilogram truck? So, probably should have stated this at the beginning, but we had to work that out in it because that was an unknown, so you're going to need to work it out. So, we know the initial velocity was 2.5 meters per second, and we now know the end velocity is 1.5 meters per second. Therefore, there's been a decrease in the velocity of 1.5 meters per second, so it's minus 1.5 meters per second. That is the change in velocity, okay? Now it's just a change, so you don't have to leave it as negative, it's just a change, okay? So, remember, the change in momentum, okay, delta mv, well, that's the change in momentum. The mass hasn't changed, obviously, so it's going to be 8,000 times 1.5 meters per second, okay, and that will obviously come to 12,000. Now, yeah, 12,000, and then that's Newton seconds, which is answer B. Okay, so for some of these multiple choice questions, you don't need to go through each answer. Okay, when it's a calculation question such as this, okay, you don't need to go through the answer. So make sure answer A, B, D, etc. is right or wrong, whatever the case may be. Okay. What you need to do, you only need to go through each answer in a multiple choice when you've got a situation where it's, you know, it's a which statement is incorrect, or what is the outcome of, you know, strongest, what are the true facts about alpha radiation, or what is meant by what was achieved by Rutherford scattering experiment. Okay, so stuff like that. So just be aware of that. Okay, so that was answer B. And oh, look, we've got one of those answers, one of those questions even. So it says for question 3, a gas molecule is moving gas molecule of mass m. Okay, so first thing I would draw is a little mass molecule, put m inside it, just so you can understand what's going on, as opposed to, you know, forgetting about that. Is moving a velocity v, collides with right angles to the side of a container, rebounds elastically. Okay, so this is the key bit. I guess you've already gone into elastic and inelastic a little bit by question 2, but it doesn't really matter. Okay, and it rebounds elastically. So essentially what's happening here is the mass is colliding with the wall. The fact it's talking about right angles means it's bouncing straight back. Okay, and it's coming back this other way. So the mass of the particle hasn't changed, and it's going there with a velocity u. Okay, and coming out with a velocity v. Now, the fact it rebounds elastically is the key bit of this question. Okay, now if anything rebounds elastically, or if anything collides elastically, what is meant is the fact that there is no loss of kinetic energy. Now, it might be a little bit of a pathetic way of remembering it, okay, but the word inelastic, okay, see, there's a couple of ways of remembering the difference, which is, you know, which conserves, momentum will always be conserved, okay, so it's obviously not to do with momentum, it's to do with kinetic energy. I always remember the first letter says what happens, okay, so there is loss of kinetic energy in an inelastic collision because it starts with I. I don't know if that helps you. If it doesn't, it doesn't. Okay? And then an elastic collision, well, I guess it doesn't work because nothing begins with E. But if you remember an inelastic because it begins with I, there is loss of kinetic energy. Then obviously the elastic is going to be where there is no loss. And you can also remember it by the fact that there is such a thing as a totally inelastic collision. And if you think about that logically, when two objects collide and move off at the same velocity, you could try and come up with an example and calculating it, but you'll find there is loss of kinetic energy when they move together. Okay, so there's a couple of ways of remembering it, but it's something you should just be able to remember anyway. So now you can say that there, because they rebound elastically, there is no loss of kinetic energy. Okay, now you should obviously be aware of the fact that the kinetic energy equation is a half of mv squared. So therefore the mass in this equation stays the same. Okay, so the only thing that can change is the velocity, and as we know, the fact that the kinetic energy before and after is the same, so therefore should the velocities and the mass be. Okay, so that means the initial velocity must be equal to the final velocity. However, because this velocity is going in an opposite direction, we also have to take into account that fact. Okay, so therefore u is equal to minus v, or v is equal to minus u. Okay, so one is the negative of the other, whichever you take the positive direction to be. I'm going to take the initial direction from left to right as being a positive, so we'll say u is actually a positive velocity, and v, because it's going in the opposite direction, we'll take that as a negative. Okay, so we'll take this equation as the thing. Okay, so that the final velocity is negative and the initial velocity is a positive. You could take it the other way around, doesn't matter, I'm waffling. Okay, so how does this help us? Well, that's just to be able to picture out what's actually happening in this. So if it comes up as one of the equations, some one of the options, which you might do, and it will do because I've looked at it, but it's just something you should be aware of. Okay, so let's go through the different options we have here. So option A says the magnitude of the magnitude of the change of momentum of the molecule is 0. Well, there's actually two here. Okay, now the way you can discount these is very easy. Okay, so let's just before we go through individually what I want to do, you will generally have, and it's quite a common thing, and it happens in this multiple choice as well. You get two options, okay, which say opposite things, okay? So if they say opposite things, one of them's right and then one of them's wrong. And if one of them's wrong, such as here, it's asking which is incorrect. If one of them is wrong and one of them must be right, then the other two possible answers must be right, because if one is right and one is wrong, then one of them is wrong, and only one of these options can be wrong, because it's asking for which is incorrect. So therefore, that must be the incorrect one. The other two are irrelevant. Okay, so I'll explain what I mean by that if that doesn't catch on. Okay, so A says the magnitude of the change of momentum is 0, the molecule is 0, whereas option B says, hang on a minute, there's actually a change of momentum here, and it's such and such 2mu. Okay, so therefore straight away you know either A or B is going to be right. Sorry, it's going to be the one that's incorrect, because they can't both be correct, because they're saying two different things. Okay, one is saying there is no change of momentum, and the other is saying there is. Okay, so therefore either there is or there isn't. So one of them has got to be wrong, and that's the one we've got to look for. Okay, but just to make sure, I mean, you can discount the other two anyway, but I'll just say what they say. Okay, so the force exerted on the molecule, the side of the container, is equal to the force exerted by the container on the molecule. Okay, so basically that's Newton's third law, saying force will always result in an equal and opposite reaction. Okay, so you know if you're pushing a fridge, the fridge is going to be acting on you. Okay, if that makes sense. Newton's third law basically says C is true. All right. D says there is a change in kinetic energy in the molecule 0. Well, we know that is correct because it rebounds elastically, so therefore there's no change in the kinetic energy. Kinetic energy is conserved. Okay, so therefore D is also correct. So that proves the fact that it's going to be A or B, because they say different things. Okay, so you can just, even without looking at C and D, I mean I would, but if you push for time, I would just cross off C. I won't even read it because A and B say different things. Okay, so therefore which is right? Now make sure you know which is right, okay, because if you didn't spot this, the fact that one is going to be a positive velocity and one is going to be a negative velocity, you can easily get this wrong, okay? So remember, a change in velocity, sorry, where am I going? A change in momentum even, although it is, a change in momentum is calculated by the momentum before take the momentum after, okay? Or the momentum after take the momentum before, whichever way round you want to say it, okay? So, it's m times u take m times v. However, the v is negative, so we're taking away a negative here. Okay, so it's mu take mv, take minus mv, so it's mu plus mv. Okay, so that's 2mu. Now the reason I can say it's 2mu is because we said u is equal to v, because for them to be for the momentum to be conserved, then u must be equal to v. Okay, so therefore u must be equal to v, so we can say both u. Right? So therefore the total momentum change is 2mu. So therefore, which says that? Okay, therefore that one must be the correct one, so the other one must be incorrect. So A says their total momentum change is 0, so therefore that's the one that's incorrect, so therefore 3 is A. Okay, hopefully you understood where that came from. So the change of momentum is worked out by the momentum before, take the momentum after. Okay, so hopefully you understood where we got that from. Okay, so that's question 3. Question 4 says, shows how the resultant force F acts on a body varies with time t. So just pause the video here. So sorry about that. So question 4 is asking about is another momentum question. Okay, and we've been given this graph. We're going to ignore that. That was totally not my writing from before. Okay, so obviously before I didn't draw the graph properly, so I messed it up. So I had to redo the video. That's why the numbers were on the side there. Okay, so basically in this we've got a question. We've got a graph here of force against time. Okay, and you should be aware of this momentum question. Now, in any graph, okay, that you're given, is generally any graph about momentum you're given in a multiple choice question, or any graph for that matter, will generally be force against time, and it will always be some variation on this equation, okay, which is the rate of change of momentum is equal to the resultant force, okay, or just force, whichever way you want to say it. Okay, so in this particular case, we've got to work out the change in momentum of this object over the period of 5 seconds, okay? So just to explain, if you can't quite see, because my graph is crap, from 0 to 1 second there is no force acting on it at all, okay? And then there's immediately a force up to, from 1, and it starts there at constant increase in force, from 1 to 2 seconds, okay, and that increases to 4 newtons, and then from 2 seconds to 4 seconds there is a constant force of 4 newtons, and then after 4 seconds there is no force at all, okay. So what we've got here basically is a triangle and a square, okay. Now it's very easy, basically. The change of momentum is, as you can see from the equation, force times time. Okay. Sorry, this is very badly drawn. So the triangle goes straight down to 1. So it's a half times 2 times half times 1 times 4. Okay. Plus 2 times 4. Okay, which is obviously 1 plus. Sorry, I'm going 2 plus 8. Right, yep, sorry, poor maths is letting me down there. So it's 10 Newton seconds, which is option C. So therefore 4 is C. Alright? hopefully that's very simple to understand, but obviously my lack of maths let me down. Okay, so that's question 4. Question 5 is quite a common one. It is about the London Eye. Okay, so we're told it has a diameter of 130 metres. Okay, equals diameter. So even though this is just a multiple choice question, I'd still list down all the bits of information that you get given. So 130 metre diameter, constant or steady speed doesn't mean that it doesn't increase velocity. Sorry, it doesn't increase speed, but it does change velocity. Completing one rotation every 30 minutes. So therefore you need to put the time, convert it into seconds. So obviously it's 30 times 60, which is 1800. So it's 1800 seconds. Just need to make sure you have that in seconds and not minutes. Okay. What is the centripetal acceleration of a person in the capsule at the rim of the wheel? Okay, so obviously the centripetal acceleration is v squared over r, and that comes from, in essence, similar triangles, but I'm not going to explain that. You just need to be aware of the equation. Okay, and also we're given diameter, so you're going to need to halve that, or you could adapt the equation to fit, but it's just easier just to half it. Okay, so that is 65, yeah. And then v squared, well, we're going to need to work v out, aren't we? So that's v squared over 65. Now v is equal to 2 pi r over t, or the centripetal, sorry, or the, name of it, freaking hell, angular speed times the radius. Okay? Whichever way, it's easier to remember it like that, because then if you need to, you can calculate. You don't have to calculate it as 2 separate equations. Okay? So it's 2 pi times the radius, so it's 2 pi times 65 over the time period, which is 1800. Okay? And to get v squared, obviously we're going to square all of that and then divide it by 65, and that's going to get us the acceleration, which should be, you should get 7.9 times 10 to the minus 4 meters per second. Okay, obviously when you convert it from pi. But some might ask it to use pi, some might give it as a pi meter per second, okay? But you look at the possible answers and they're all in standard form, okay? So therefore, this is the answer we're looking for, because that's the answer we've got, and that's option D, so 5 is D. Now, as I said, this is another question where you don't have to check each answer individually. You just need to go through and make sure you've not missed anything out when you're working, because, say for example, if you did that but didn't convert the time into SI units, the answer would also be one of them. Okay, so even though you get the answer, that is one of the options, might not necessarily be the right one. Okay, just to fill you with competence, even more than you already are. Okay, so but just make sure you convert the units. That's the main thing they catch you out on. So as long as you convert the units and you get one of the answers, that should be right. Okay, so that's question 5. Question 6 says a small body of mass m rests on a horizontal turntable distance r from the centre. If the maximum frictional force between the body and the turntable is mg over 2, what is the angular speed at which the body starts to slip? Okay, so this is centripetal force, this is centripetal acceleration. So what I would do is draw yourself a little circle. So we've got the centre of the circle there, looks very much like something that should be on red tube, but never mind. So we've got a particle here, and let's just draw the forces acting on it so we can make sense of what it's saying. Okay, so you should know that the centripetal acceleration works towards the centre. So therefore, that's F, we'll label that as F. And you know the centripetal acceleration is equal to mv squared over 2. Okay, obviously that comes from ma, a being v squared over 2. So that's the force towards the centre. Now, it's told us a key bit of information here. Obviously there is going to be a velocity going this way, but what is the force pulling it outwards? Because obviously if there's only a force pulling it inwards, it would go towards the centre. But it doesn't, it stays in a constant radius. Okay, and it says the maximum frictional force is mg over 2. So there, the frictional force goes in the opposite direction to motion. Okay, now actually the motion going towards the circle centre, so therefore going away must be mg over 2. Okay, so what we've got to do here is say, well, all the forces must be balanced. Obviously there is another force pulling it this way, okay, otherwise, sorry, there's not another force pulling that way, because if there was a force pulling it that way, then it would stay exactly where it is, but it goes around the circle, so these are the only forces acting on this little object here. Okay, so therefore, the two forces that balance are mg over 2 and mv squared over r. Now, what we need ideally, because we've got to find out v, is we've got to have an equation where v is involved, and obviously there is, okay? So, therefore, mv squared over 2 is equal to mg over 2, so we put them two equal, that's the first stage. mv squared over r and mg over 2. Now, this is actually quite a common procedure, so just be aware of how to work this out. Okay, it might not be equal to mg over 2, but that's just an example. Okay, so what we want is v on its own. Okay, so when, however, they're not equal, even though they are here, you've got to breathe into the question a bit more. Okay, what is the maximum frictional force when the body starts to slip? Okay, so it is when they are equal to each other, because just after this point, okay, they begin to slip. Okay, so when the frictional force, when the centripetal force is greater than the force pulling it outwards, it will start to move in, and obviously when this is greater than that, it will start to slip out. Okay, so just be aware of that. Okay, but you don't have to put the greater than or equal to signs in here, because it's not saying you know, given a certain speed, will it slip at this point? It's just saying what speed will it start to slip at. So at this point, it is starting. It's not slipping; it's starting to. Okay, so just be aware of the terminology there. Okay, so we want v on its own. Now, you can quite clearly see we can cancel the two m's straight away. Okay, so left with v squared over r is equal to g over 2. Okay, and what we want is this v on its own, so therefore times r across. Okay, so v squared equal to gr over 2. Square root both sides, so to get v is equal to the square root gr over 2. And we're looking for that as a possible answer. Okay, so if we look. Oh, have I done that right? I think I've done that right, have I? Oh, sorry, yes. See what I've done here. Now, what I've done is actually a common mistake, so I do apologise. It's a lot. This will be option A. Okay. I've obviously done this on purpose, which it isn't. By the way, the answer is C. Now, the reason I've done this wrong, okay, is quite easy, and it's quite an honest mistake to make. Okay, it's because I was trying to rush through the question and I just make sure it was incorrect, and I was. It's not asking for the speed; it's asking for the angular speed. Now, the angular speed different to the speed because the speed is 2 pi r over t, okay, and we know the angular speed is 2 pi over t. Okay, in other words, the angular speed is equal to the velocity divided by the radius, or the velocity is equal to the radius times the angular speed. But in the case we're interested in, we need to divide the velocity by the radius. Okay, so we can get to this stage. So I haven't done it wrong, I've just not finished it off. Okay, so if we divide this by the radius, okay, what we get is the v is equal to the square root of g over 2r. Okay, divided by the radius. And obviously, we're dividing because it's squared. Okay. Oh, you could do it from this point actually. Could you? Swear you'd fit that in. Yeah, you could do that. If you understand that, great. If you don't, have another look for you. Yeah, you could either go at this point or work from this point here. So we've got v squared over r is equal to g over 2, okay? And remember, the velocity is so the angular speed is equal to the velocity over the radius. So at this point, you could divide both sides by the radius, okay? So that would obviously be divided by 2r, and that would be divided by r, okay? And then, sorry. Yeah, that'll be over 2r, okay? And then obviously you times that across, you get the 2r over here, and then that obviously turns to the angular speed, and we get to this point, okay? So hopefully that makes sense to you. If it doesn't, please do let me know in the comments, and I'll have another go at that, but sorry about that. But you can see how easy it is